Righto, moving right along to uh, the Algebra Level 2 NCEA exam for this year. Let me just change the volume just a little bit so I'm not screaming in your head. The exam apparently was pretty difficult. A lot of students have told me that they found this a bit on the difficult end. So with that, let's give it a go. All right, we're going to be just using, if ever possible, the formula that they give you. Obviously, we won't need the calculus, but we'll probably need this, and we'll probably need this. And I'll be using the FX82 calculator, which is the most common calculator that students use. All right. So the first one is, let's start off fairly simple. So we want to simplify 5y times square root of 6, y to the power of 6 over 64. So let's sort of take this square root first. Let's ignore the 5y for now. Okay, when we do that, we can always rewrite that as the square root of y to the 6th over the square root of 64, and there is going to be a 2 there, so this is going to be y to the power of 3. Just remember, if we take the square root, it's the same thing as raising it to the power of half, and 6 times a half is 3, over square root of 64 is, of course, 8. So 5y times y cubed over 8. Now I guess if we multiply these out again, we're going to get 5y to the power of 4 over 8. I think that's probably about as much as it's going to simplify. We don't really want to put it into decimal fractions. So that's the final answer for that one, I think. Okay, that's an okay start. So rearrange the expression. 2y equals the cube root of everything in the brackets here, 7x minus 5. Well, this radical sign here is wanting to be undone, so let's just cube both sides. Remember, when we have something which is cube root and we cube it, they cancel each other out. So 2y to the power of 3 is going to be 8y cubed, and that's going to be equal to 7x minus 5. And what are they wanting us to do? They're wanting to rearrange to make x the subject. Okay, let's take this 5 away from both sides. Add 5 to both sides, I should say. Now we're going to divide both sides by 7, and come down here, and our final answer is going to be x equals, so that's going to cancel obviously, 8y cubed plus 5 all over 7. Can we simplify it anymore? No, I don't think we can. That's our answer. All right. Someone did send me a message, and it was actually pretty good advice. They said your scribbles get a bit all over the place. Can you highlight the actual final answers? So I thought that was a really, really great idea. So from now on, I'm going to be doing that to my final answer. Good idea. In the exam, you can always circle it to let the marker know that it's that's your final answer. Okay, so now we're given this parabola, and we're told that it has this equation here, y equals 2x squared plus a, which we don't know, x plus b, which we don't know. A and b are both constants. Okay, so they're constants. One of the points where it crosses the x-axis is at 1.5 comma 0, and the other one is at -5, -1, -5. Find the values of a and b. Okay, well, let's put them into our form, our sort of standard form of a parabola. I'm kind of umming and ahhing a little bit today. Plus ax plus b. Okay, let's put the 1.5 and 0. So that tells us that when x equals 1.5, y equals 0, it's going to be equal to 2 times 1.5 squared plus a times 1.5 plus b. So let's deal with this first. So 1.5 squared is 2.25 off the top of my head, and 2 times 2.5 is going to be, what's that going to be? 4.5. 4.5. So 0 equals 4.5 plus 1.5 a plus b. And let's bring this 4.5 across here, and I'm going to get rid of it, and then I'm going to put it there, -1 minus 4.5, just to, I can see where we're going. We're going to need to create a set of simultaneous equations, so I've just got that there. The other one is -1 minus 5. Okay. So, so 2 times -1 squared, -1 squared is +1. 2 times +1 is obviously 2. So we've got 2 plus, and x is 1.5. X is -1 times a. So let's rub all of that out. -1. 2 minus 1a and plus b, and we know that that equals -5. Let's bring this. Oh, have I done a mistake here? Have I done a mistake? I don't know whether I've done a mistake, but it's definitely messy. Hang on. Right, this question caused quite a few people a bit of trouble, so let's go through it. It's the first time I've seen it myself. So we're told that the rectangle inscribed means inside, with the corners touching the circle, with a radius 5 of the diagram. The length of the rectangle is twice its width. Okay. I think this is the thing. A lot of people may not have read that bit. So the length, that is from left to right, of this is twice as much as the height. The width, as they call it.
Okay, so if we have our sort of just this bit here, let's have a look at it. So it's a right angle triangle. So that side is R. That's the right angle triangle, and this is along the x-axis. So let's call this x, and then we know that this side here is half that, so we're going to call it half x. All right. So the area of this whole grey square here is going to be 2x, isn't it? Because it's x from here to here, so it's 2x from here to here, 2x, and that's going to be times x over 2 times 2 is x. Sorry, not 2, x. So that's going to be 2x squared. So the area is going to be 2x squared. And they want the area of the rectangle in terms of r. And I think there's a formula that I've seen that links both of those together. But let's sort of pretend we don't know that for now. I certainly don't expect you to know that. So the area is, let's write that out. It's not very neat. So the area is that. But we want the area in terms of, find the area of the rectangle in terms of r. Okay, so for this we'll use Pythagoras' theorem for that. So a squared plus b squared equals c squared. So c is going to be r. So r squared is going to be equal to x squared plus x over 2 squared. So r squared is going to be equal to x squared plus x squared over 4. Adding those together is going to be a bit of a little bit of a hassle. It's going to be 5 over 4, but let's put a 4 there and a 4 there so we can have a common denominator. Again, if I multiply by 4 and divide by 4, they're kind of going to even out to 1. So r squared is going to be equal to 4x squared over 4 plus x over x squared over 4, and that's going to be equal to 5x squared over 4. So that's good. Now, does this help us at all? If we had x squared here in terms of r, we know that there is an x squared in the final formula that we want. So we're kind of there. So r squared is 5x squared over 4. So let's multiply both sides by 4. So 4r squared equals 5x squared. And then we want to divide both sides by 5. Yes, we want to divide both sides by 5, and it's going to give us x squared. Yes, 4 over 5. Yes, so x squared is going to be 4r squared over 5. And we know that the area is twice that. So therefore the area is going to be 2 times 4r squared over 5, which is going to be 8r squared over 5. Does it simplify anymore? Nope. And I think that's our final answer. Huh. There you go. Alright, this next one looks a little bit trickier. How are we going to end this one? Well, let's take their advice straight away. Because these are 5 and there's an x in there, and there's a 5 and there's an x in there, and I don't think there is any number there that equals 120 where this is a nice number, so we'll forget about that. I think it goes to 125, which means 120 itself doesn't work. Okay. So I want to find 5x. Okay. So this first one. Okay, so let's take this first. This first term here. So that's we can rewrite that as 5 to the 2x times 5 to the 1. And 5 to the 1 is 5. To x. And we want 5x, so we're almost there. And if we take the x away, we would get that. Okay, the minus 120. I don't think we can do anything, so we're going to park it for now. The 5x plus 2 is going to be equal to 5x times 5 squared. Remember your rules of indices. So that's already in. So, and 5 squared is 25. So this is 25, 5 of x. And now I'm going to let 5 of x be equal to n. So this one here becomes 5n squared minus 120 is going to be equal to 25 times n. And now we want to solve for n, and it's kind of already in a quadratic format, so let's do that. So we've got 5n squared minus 25n minus 120 equals 0. I put the 25n across. And now we can see something very, very, very familiar. Now if I divide everything here by 5, divide both sides by 5. It's obviously not going to matter because 0 divided by 5 is 0. We get n squared minus 5n minus 24. Because 25 is 100, 21, 5s is 105, 110, 150, 120 is 24. Equals 0. And now we're starting to really make sense. So we want two numbers that multiply together to give us negative 28 and add to give us negative 5. Well, it's going to be x 8 and 3 minus 8 and x plus 3 equals, not x, n equals 0. So n minus 8 equals 0. So n equals positive 8 and n equals negative 3. Now, we didn't ask, we weren't asked originally for n, we were asked for x. On to question 2. What is the k needed to write nx squared minus 30x plus k as a perfect square? So a perfect square, of course, is sort of a plus a b, that. So in order to do that, I can think of a couple of ways to do it. There's a cute way of doing it, but let's use it doing the brute method force. That always works. Alright, let's do the discriminant. And we know that when the discriminant is 0, that is b squared minus 4ac equals 0, then we've got one solution, and that solution must be a perfect solution. So what is a, b, and c in this case? Well, a is going to be equal to 9. B is going to be equal to minus 30, and C is going to be equal to K. So we want to find 9 squared minus 4 times 9 for AC. No, it's not going to be 30 squared, is it? What am I saying? It's going to be, it's not going to be 9 squared, it's going to be 30 squared, isn't it? 30 squared minus 30 squared. Actually, it won't matter, because minus 30 squared is the same as 30 squared. Minus 4 times 9 times K, and that's going to equal 0. So 90 squared is, I think, 900, minus 4 times 9 is 36, K equals 0. So we can get rid of those brackets, can't we? 900 minus 36K, what am I saying? Equals 0. So let's work out K. K is going to be minus 900 divided by minus 36, and I have no idea what that is off the top of my head. There's the last question. 900 divided by 36 is 25. 25. K equals 25, and you can test that. If we were to graph that, it would have an embrace on the x-axis. It will come down and touch it and then move straight back off again. But for now, I think that's an okay answer. All right, this one here. Simplify fully. 6x cubed plus 26 squared minus 20x over 5x squared plus 23x plus 10. So they're both sort of crying out to be factorized. So let's factorize the bottom one first. Is there a common factor? I'm going to take out 2x. So I've got 3x squared plus 12x minus 10. And there, is there any way we can simplify that one anymore? Anything more we can factor out? Nope. Okay, so let's factorize this one. So 3 times negative 10 is negative 30. So we want two factors to multiply to give us negative 30 and add to give us positive 12. Positive 13. It's 13, isn't it? 2x times 13x is 26x. So for that, it's going to be positive 15 and negative 2, isn't it? Yeah. I was thinking 10 times 3, and no, there's no way that can be there. So, okay, so I'm going to take the 2x out the front. And I'm going to say 3x squared plus 15x minus 2x minus 10. So the 2x stays there. And I'm going to factorize the first two. So 3x x plus 5. And then for these ones here, if we have x plus 5 here, minus 2. Because minus 2 times x is minus 2x, and minus 2 times 5 is negative 10. So this is going to be 2x, 3x minus 2, x plus 5. And now let's do the denominator down here. So 5x squared plus 23x minus 10. Okay, so 5 times, do the simplify anymore? No, 23 is a prime number. Okay, so 5 times negative 10 is negative 50. So we need some number that multiplies to give us negative 50 and adds to give us positive 23. What's going to be obviously 25 and negative 2. So we are going to separate that out into its components. 5x squared plus 25x, and that's going to factorize nicely, minus 2x minus 10. So this is going to be 5x x plus 5 minus 2x plus 5. So we've got 5x minus 2. Collect the outside terms, then collect the inside terms, and that's what we get for that. So when we combine them together, we get this, combine it with this. So we have 2x, 3x minus 2, x plus 5 over 5x minus 2, x plus 5. Well, how about that? They're going to cancel. And we're left with 2x, 3x minus 2 over 5x minus 2. Does that simplify any more if we expand out that bracket and play around with it again? No, I don't think that's... I think that's as simplified as it's going to get. Maybe expand out that brackets there, but no real point. So that would be our final answer. Alright, the next one is a bit of a tricky one. The solutions to the equation 10 over brackets 3x minus 1 or squared equals 2 can be written in the form 1 plus some square root of a over b and 1 minus square root of a over b. Find the values of a and b. Don't know whether they want a and b as integers, but I can think of two ways of doing it. One way would be the brute force method using the quadratic equation, and I imagine that would get pretty nasty pretty quickly, or you could just go straight to the answer. I think I might like put a little square there, a star there, because I might do a little video on how you would do it using the quadratic equation. My bet is that a lot of people looked at that and go, oh, that sort of looks like the quadratic equation, and I would say you could definitely get there, but let's do the quick one first. So we've got 10 over 3x minus 1 squared equals 20. First thing I'm going to do is I'm going to multiply bottom to top here. So I'm going to get 10 equals not 20. It's not 20, it's 10. I'm going to multiply it across. So 2, 3x minus 1 squared. Alright. Then I'm going to divide both sides by 2. Let's simplify things as much as possible. We get rid of that. That becomes a 5. 10 divided by 2 is 5. Okay. So let's rewrite it a little bit. So 3x minus 1 squared equals 5. Now what do? Let's take the square root of both sides. So 3x minus 1 equals square root 5. Now remember, when we square root, we have to say plus minus the square root of 5. And that's going to meet our criteria up here. And now it's just a matter of our algebra. So we're going to add 1 to both sides. So 3x, and I'm going to put this plus 1 at the front so it's already in the form that we want. 1 plus square root 5. And then I'm going to divide both sides by 3. They cancel, and hey presto, like magic, we get the answer. So A is the thing in the brackets, 5, and B is the thing down below, which is 3. Again, you could get that a couple of ways, including the quadratic equation, which I'll do in a sort of sub video, but that's the quickest way of doing it. Alright, our next question, we start using logs explicitly. So we're told to solve the equation 2 log base 5 brackets x plus 6 minus log base 5x minus 2 equals 0. First thing I'm going to do, I'm going to bring this this 2 across, so it's not sort of caught up in the crossfire of when we start firing off these logs. So if they're both base 5, that's good. This one here kind of looks like a bit of a mouthful, so I'm going to rewrite that log base 5 6x x plus 6 2. Remember, we can do that with a log. That 2 can sort of jump back and forth as much as it wants without altering it. And what can we do here? And it's going to be minus, so this is gone. So it's going to be minus log 5, which is the same as over x, isn't it? Equals 2. Yes, because they're minus, yeah, the log a of b minus log a of c equals log a b over c. Yes, that's the rule. Okay, now what do we want to do? Well, we want to exponentiate everything. So I'm going to raise this 5 to the power of this equals 5 to the power of this. The log 5 and the raise the log cancel each other out, and that should be a 6, not a b. So we get x plus 6 squared over x equals 5 to the power of 2, which is 25. So therefore x plus 6 squared is going to be equal to 25x, and that's nice. And then I'm going to, what am I going to do there? Oh, let's expand out of this bracket so it's in quadratic form, I think. So x plus 6, x plus 6, if you remember when you multiply things out, it's going to be x squared plus 2 times 6 is 12x. 6 times 6 is 36 equals 25x. Okay, that's all starting to look good and proper. Let's take the 25x from this side over to this side. So we've got x squared, 12 minus 25 is minus 13x, plus 63 equals 0. 63? 36. Whoa. I transpose the 3 and the x, the 3 and the 6. 63. Transpose the 6 and the 3. Okay. Now, what do we want to do? Is there any way we can simplify this a little bit more before we factorize? No, there isn't. And there's nothing in front of that. So, two numbers that multiply to give us 36 and add to give us minus 13. 9 and 3, no, 10 and no, 9 and 4, Yes, x minus 4, x minus 9 equals 0, which means that x must be either 4 or 9 or both. Now we're going to need to do a sanity check. So we started with at the beginning of this, we started with this. So if we substitute in x equals 4 and x equals 9, are we going to get real answers? Log 5 of, if that is x, log 5 of 10, that's a valid number. Log 5 of 4, that's a valid number. Log 5 of 15, that's 9 plus 6, is a valid number. And log, so both of these are valid number. So x must equal 4 and 9. They're both valid numbers. This question is a bit of a funny one. So the values of x and y satisfy simultaneous equations. Y minus 2x equals 13, and x squared plus 2ky equals 6k, where k is a non-zero constant. There is one solution to the equations that's going to help us, and there's an x squared there. Find the value of k. Okay, well, first thing I want to do, I want to get rid of one of x and y. And y looks like our primary suspect. If we bring this negative 2x over, we get y equals 2x plus 13. And then we can put that into the other equation. Right, we can substitute it straight in. We've got y there, so we have our golden ticket to the chocolate factory. We'll put it there. All right, so then what we would have is 2k times 2x plus 13 equals 6k. Okay, so we're making progress. We would expand that as 2x, x squared plus 4k x. Remember, k is a constant, so that's going to be our constant for there. And 2k times 13 is 26k equals 6k, and this is starting to look like a quadratic. So let's bring this 6k over, take 6k away from both sides. So x squared plus 4k x plus 20k equals 0. Okay. And because there's one solution, the determinant must be equal to 0. So b squared minus 4ac, which is the determinant, must equal 0, where b in this case is 4k squared minus 4 times 1. There's a 1 in front of the x squared. X squared 4b 4 times 1 times c is 20k, and we know that equals 0. Okay, so this is going to be 16k squared minus 80k equals 0. Yes, we can do this. We have one equation and one unknown. Okay, now do these all divide by some number? Is 18 a multiple of 16? 80, 16 equals 5. Okay, it does. So 16k, k minus 5 equals 0. So k must equal either 0 or positive 5. Now, are any of these not allowed? K is a non-zero constant, so therefore it's not allowed. So therefore k must equal 5. And that's our final answer. Hooray. We're up to question 3. We go past it. All right. Log base square root of x, 8 equals 6. So it's kind of expand this out now in our terms that we're familiar with. Equals 8. Okay, so x to the power of x square root is the same as x to the power of half. So x to the power of half times 6 equals 8. So x cubed equals 8. You really shouldn't need a calculator for that. X times x times x equals 8. X must be equal to 2, and there's our answer. All right, so this one tells us this: the quadratic equation has these solutions here. Now, find A, B, and C. Now, there's a couple of ways of doing it. We could say, okay, so we've got the two roots, so we know that y must be equal to a x minus root 1, x minus root 2, and then solve. You could do that, and you would get, after a while, you would get a quadratic equation, and they would pop out eventually. They're integer values, so we're going to need to sort of play around with it a little bit after that. But with all of this stuff, let's just remember, when we factorize things, we always got x minus the root, and that equals 0. Root 1 and x minus the root 2 equals 0, and that was the root. So we set them equal to 0 and solved. So let's do, I can't remember what this is called. I think this is called reverse factorizing, or it's probably a name for it. But in other words, the x value is going to be equal to 1/5, and the other x value is going to be equal to -2/3. So you want to bring everything over and then set that equal to 0. So you got something equal to 0. So I'm going to multiply both sides by 5. So 5x equals 1. I'm going to take this 1 across. So 5x minus 1 must be one of the brackets. And for this one here, I'm going to multiply everything by 3. So we have 3x equals -2. And then we're going to add 2 to both sides. 3x plus 2. That must also equal 0. So now we're just going to multiply those together to get the original equation. It's just a nifty little trick. So we've got 15x squared minus 3x plus 10x minus 2. So we've got 15x squared plus 7x minus 2. So therefore A is 15, B is 7, and C is minus 2. That's the wonkiest 2 ever written. Minus 2. And that's our answer for that one. In fact, that's a terrible. I should be ashamed of myself putting a 2 like that in. Is minus 2. And don't forget to highlight it. Yep, and we're done. Alright, so for this one, this looks quite tricky. Okay, so P is log A of 3 and Q is log A of 5. Right, log 75 in terms of P and Q. So 3 and 5 are both prime numbers. So 75, we want it in terms of 3 and 5. It's going to be equal to, well, 3 times 25 is 75, and 25 is itself 5 times 5. So that's going to be our in, I think. Yeah, that's going to be our in. Okay. So log A of 75 is going to be equal to log A of 3 times 5. I'm just going to say 5 squared. Yeah, because that's going to help us a lot, because this is in 5. Okay. Now, we can rewrite that as log base A 3 times 2 log base A of 5. And log base A of 5 is Q. And log base A of 3 is P. And there's 2 of them. So, therefore, log A of 75 is going to be equal to P plus 2Q. Yeah. There's not going to be times there, there's going to be plus. When we add two things together, multiply things together, we add them together. Yeah, that makes sense. So that's going to be plus. So maybe I should. And that's that done. It looks really, really complicated. Should be complicated, more complicated than that. I don't think I made a mistake. All right, let's move on. So, this is a tough one. I recognize this as one of Vieta's equations or formula. Could we find a solution? Maybe. I may come back and see if I can see a solution that uses one of the things that you're given there. But I would do it using the Vieta's method. So first thing I'm going to do is I'm going to do that, and it's the roots that we've got. Expression square, sum of squares. If A and B are the solutions, then this must be true. So if A and B are the solutions, that has to be true. Okay. Next thing I'm going to do is I'm going to expand out those brackets. So first in, last out. So I'm going to do x squared minus ax minus bx plus ab, and that's going to equal 0. Okay, and then I'm going to factor out the x to the power of 1 from the terms that have it in it. So x squared is going to be equal to minus a plus b x. I'm going to have it in that form there rather than having the x at the front. And let's take out the little bit of scribble. Okay, and then the AB is gonna, nope, not 2AB, different one. AB equals 0, and we're starting to look a bit better. All right, now what do we do? Now comes the really tricky bit. If you have a look at this, this is x squared minus this, and also we have this form here. So in other words, minus a plus b must equal minus m from our equation up here. That means that m must be a plus b. Okay, so that's good. Now we want to compare these constant terms. AB here must equal n. So that's got to be m, that's got to be n. All right, so n equals a times b. So far so good. Now we have AB and we have a plus b in the brackets. We have a plus b up here, and we have AB, and we can substitute that in N and M now. Okay, so what it tells us is that A squared plus B squared, which is in fact what we were trying to find out in the first place, is going to be equal to A plus B, which is M squared, minus 2 times AB, which was N. So A squared plus B squared equals M squared minus 2N. We're done. Vieta, this little nifty little thing helps us a lot. We could do it by brute force, expanding things out, but I imagine it would get messy really quickly. That's the quick and nasty way to do it. It is in the syllabus. Maybe you just didn't remember doing it, if you could remember doing it. But it is quite nifty little trick.
Okay, the last question is about golf. So Shiloh is about to play golf. She tees off from TA and she doesn't want to go the normal route, which is down this way and then to the tee. She wants to go, all the marbles. Let's go do all of this in one shot. So then it tells us that the tee is 2 meters above ground level, which is here, and the maximum height it reaches is 20 meters, 110 from the start, and the tree is 7.5 meters and is 200 meters away from the start.
What, are we waiting for these guys? Hey, Whitey, where's your hat? Let's go while we're young.
You mind, sir, trying to tee off?
I bet you slice into the woods $100. Damn! Okay, you can owe me.
So first thing I'm going to do, I'm going to sort of note that this is a parabola, and I'm going to set the origin point here. And the reason I'm going to do that, you'll see why in a second. So I know that this is a parabola and it's going to take off at point 0, 0. If we had the 0 point down here, it's going to be messy. So that tells us that it's fine if the x-axis goes along here and it's going to cut 2 meters off the height. So 110 meters after we start. The height is not 20 meters, it's 18 meters above the tee. And the tree now is going to be 200 meters down. We don't know the height. But the tree, actually we do know the height. The tree itself is 7.5 meters. When we take that 2 meters off, it's 5.2. And another point that is not necessarily given to us is this point here. It's a parabola. If it reaches its height at 110, it must reach 0 again at 220. Okay. Now we have enough to put all of these into a simultaneous equation. And I'm not going to do that. I'm just going to grab my calculator, to be honest, and do it. So let's get our calculator when it wants to start running. There we go. Let's go to main, and I'm going to do a regression. So I'm going to go to menu, stat, and I'm going to enter these 3 points. And we don't want to put the point of the tree because we don't know if the tree is on there. So 0, 0, 110, 18, and 220, 0. Okay, I'm going to go across. So 0, 0, 18, and 0 again. And it's going to give us the equation for this graph. And I need it parabolic. And it gives it to us in this form here. So the height as a function of x, let's say, is going to be given as minus 1.487 times 10 to the negative 3 x squared plus 0.327 to 7 x, and then plus c is 0, obviously, because through the origin point the c is going to be 0. Then I'm going to go to the grapher function, and I'm going to put this in. So negative 1.487 to the power of negative 3 x squared plus 0.327 to 7x. Put it in our function, and that's that's the function that we've got there. Now we want to find out what will the y value be when x is 200. If it's more than if it's more than 5.5, should be 5.2, should be 5.5, we're fine. If it's less than 5.5, it's going to hit the tree. Okay? So, let's put it in our calculator. So, y calculate x is 200. 5.974. So at 200, where the tree is, the height is going to be equal to 5.974. We want it above, so it's going to be 47 centimeters clearance. So yes, it works. Physics works. Algebra works. There we go.